Okay. And this fast load, as its name indicates, the purpose of this is loading data fast. That's it, simple. It is to load the data fast into Teradata RDBMS from the files or data sets if it is a mainframe. So from mainframe data sets or the network attached files, the flat files, it can load the data in very fast. So what is the purpose? Inserts large amounts of data into a single empty table at very high speed. Okay, so the single statement describes 80% of the fast load. So please observe each word here. It inserts the large amounts of data, so it is not suitable for very less number of data. Okay. If the data is very large, you go for this. So it inserts large amounts of data into a single table. So fast load can load only one table. It cannot load multiple tables. Okay. And the target table should be empty. Okay. If the target table is empty and if you are intended to load only one single empty table and the input has very huge data, then you can opt for this utility for a high speed load. When I say high speed, it is not a row level operation. It is a bulk operation where it uses 64 kilobytes of memory to spool the input data into this memory and then do a single operation on all the records which are accommodated in the 64 kilobytes of memory. Okay, so that is the feature of the fast load, okay, which is used to insert huge amount of data into a single empty table with a high speed. And it can be executed on network attached servers and the mainframe servers. And with the JDBC, you can use it through Java related applications. And load data in stages. It won't load in one phase. It uses two phases to load the data into the target table. Okay. And while inserting, it can insert from multiple separate batches. Input data may be loaded from multiple separate batches. Okay, so, for example, if I am getting the customer data from one branch at 4 a.m. and another branch at 5 a.m. Both are customer data in the same format, the same delimiters and same protocol. Okay, I want to load these two customer batches into a single customer table. So I can use fast load. Then you may get a question. If I use fast load to load the first batch of data into the table, then table has the data, and when the second batch file arrive, how I can load the already populated table with fast load? Because fast load constraint is the single empty table, right? So when I loaded the first batch of data into the customer table, that means it has the data, and when the second file arrives, how I can load it into the table which was already populated with the data. Okay? But there is an option. There is a workaround what we can do to load multiple separate batches into a single empty table. Okay, I will show you that. There is an exercise how we can load multiple batch files through fast load into a single table. We'll do that. Okay. And it can be executed in batch or interactive mode. Interactive mode means you execute a command, it gives the result, and then after seeing the result, you will execute one more command. That is an interactive mode. Or you can group all the commands as a single script and can execute at once. That is the batch mode. And it supports the in-mode routines. What is this in-mode? The in-mode is the routine which could be written in any third-party language program like Java, COBOL, C, C++, whatever program you want to write in other third-party languages, you can write them, you can compile them, and the compiled object code, the executable object code, you can invoke through the fast load utility. In case before loading the data, if you want to do some operations on the data, okay, for example, from my source system I am getting a file of 100 columns, but while loading into the fast load I have to do some little transformations, like the third field and the fifth field should be concatenated, and the last 90 columns to be dropped. This is my requirement before I load. So what I can do, I can write a program in C, C++ or shell scripts or in Java, COBOL to do all these little transformations on the data before I load into the Teradata. And this object code, which can do some transformations on the file, can be invoked through fast load, so that first it will execute and it will make the format of the data. It gives a new output file for me for fast load, and then fast load will execute on the new output file. Like that we can do, or we can achieve transformations which are written in other third-party language programs. So InMode has an ability to invoke the third-party language object codes within it, so that it will execute first and it will prepare the file to load through fast load. And then input data that fails to load is saved in error table. While loading the data, when you are loading huge data, millions of data, if any data record is not as per the expectation, then those error records are saved in a separate structure called error tables. Because in FastLoad we have error tables. Okay, it not only gives you the error message and error code, but it will also capture the erroneous record into a separate structure called error table. In BTQ, in BTech, it cannot capture you the error record. It just gives you what happened, okay, what the error message and what record it has happened, but it cannot capture the erroneous record. But here in FastLoad you have a separate structure called error table, where it can help you to capture the error records also in separate structure. And input data error limit may be set. That means while loading the data, if some error happened, what happens generally in BTQ? For example, if we consider a BTQ, I am loading some 1000 records and some error happened at 995th record. Then what happens? It just comes out of it by specifying got an error at 995 records due to some so and so error. That's it. It just comes out of it, execution. Right? But here in FastLoad, you can set the error limit. That means how many errors it can tolerate. Because we are loading huge data here. It is not 1000 records, 2000 records. It is intended for large amount. And suppose if you are loading some 10 million records and there is one error at the 100th record. So shall I discard all remaining 9.9 million records? No, right? It is not valid. If one record is wrong, why I reject all the 10 million records? So here in FastLoad, there is an option where you can set the error limit that you can tolerate 100 errors in 10 million rows. That is maybe 0.1% error you are tolerating. Like that, you can specify that error limit in the FastLoad, so it can still observe the errors. Whenever the error records occur, it will capture them in the error table and it will continue with the proper records. So it will do that up to 100 errors, and when one error happened, then it will come out of the execution saying there are more errors than the threshold. Okay, so there is an option in fast load where you can set the error limit, whether it is 1 error or 100 errors or 1000 errors. It is based on our data and our fault tolerance activity. How many errors you can accept? That limit you can specify in fast load. But in BTIC we don't have that feature. Okay, after 999 records, if error happen, it will just come out of it, and we have to start from the start after fixing the error. But here we have the feature of error limit where it can accept some errors, and we have the checkpoint features in fast load. Again, if we see the same example, you are loading 1000 records with the BTQ, and at 999 record something happened, it failed, and you saw the error, you fixed it, and then again you are loading it. It has to start from 0 record onwards in BTQ. Right? But here what happens, while loading the data, it has a feature of checkpoint. That means after certain number of rows loaded successfully, it will use a log file to do the checkpointing. That means it will just note down, okay, the first million records are loaded successfully. It will note a journal or checkpoints in the log. After second million rows inserted, then again it will write a note that the second million also executed successfully. After 3 million, after 4th million, after 5th million. Okay. At the 9th million, if I get an error, that means it already satisfied the error limit, and I got 101 error, it come out of the execution. Okay. And I saw the error tables, I saw the error messages, I fixed it, and when I rerun it, it will start from the last checkpoint onwards, but not from the 0th record. Okay, so the 9 checkpoints happened, that means 9 million records are successfully loaded, so I have to start from 9 million and first record onwards. That is the advantage of checkpointing. So fastload has a feature of checkpoint where you can specify after how many number of records it has to note the progress of the load, so that it will keep on logging in the status information after those many number of records, and whenever a failure occurs and when you restart by fixing the problem, it will start from the last checkpoint onwards. So we are saving some resources, because we may load 100 millions of data. After 99 million records something happened, it was already taken some huge resources from CPU on perspective, for IO perspective, for time perspective. It has taken a lot of resources to load 99 million record, and after that if the error threshold is exceeded and it failed, and after fixing it, if you run it, if it starts from the 99 million record onwards, then you are saving so many resources, right? So that feature exists in the fast load. So these are the actual features or characteristics or functionalities of the fast load. And coming to the restrictions or limitations of the fast load, you can see this. The target table must be empty initially. That's what we told here from the first feature onwards, right? So most of the times, if you don't have, most of the times the staging tables are always empty, because every day we load today's data by deleting the yesterday's data. So for staging tables, it is very suitable. It should be always empty. But if you have a scenario where you cannot delete the data, then you have to take a workaround. You may have to take a backup, or you have to create some pre-temp tables to populate and then load into here, or something you have to do. So the limitation is the target table should be empty if you would like to use the fast load. Then the target table cannot have secondary indexes, join indexes, or hash indexes, because all these indexes are the subtables created on the target table. Whenever the main table is populated, these subtables would also be populated with the corresponding data. But fast load can load only one table, and it is intended for fast load. If it start loading all the second index tables, join index tables, hash index tables, it would take a lot of time, and anyway it cannot access multiple tables in a single session, right? In a single fast load utility, it cannot support multiple tables, so it cannot support the sub table indexes. Only the primary index and partition primary index, which are not having subtables, are supported here, but not the subtable indexes. Okay, so we have to ensure the target table is not defined with any of the subtable indexes if you would like to use fast load on the table. If they have, again a workaround has to be done. Okay, you have to see, if I drop the index before load and after loading, if I recreate the index, how much resources it is taking, and if I do this load with BTQ or some other utility some other utility, how much resources it is taking, and you do a feasibility study. Okay, you may drop the index and then load the table with fast load and then recreate the index. That could be a scenario. Okay, if you want to use fast load on the table which already has the subtable index defined. Okay. And then referential integrity constraints are not supported. What is the referential integrity? The foreign key and primary key relationship. Generally in Teradata, in physical model of Teradata, we don't use the foreign key and primary key relationships. Right? All tables are isolated. We load everything without validating the data while loading, but after loading we'll do the joins and we'll try to find out which are the invalid records, and when we report them to the users to take further actions. But while loading we don't restrict anything. Whatever is coming from source, just load it. So generally we don't use referential integrity, but even if you have a referential integrity, it is not supported in fast load. You may have to drop that integrity first and then load it, then recreate the integrity. Or the workaround is the soft RA. That means first load it and then do a join with the master and child table, find out the erroneous records and report them or delete them if you are competent. That is the soft referential integrity. We don't physically maintain the referential integrity with the primary key and foreign key relationships, but we load the data and find out the errors later after load. That is soft referential integrity. Okay. And the target table cannot have triggers, the event based triggers. And whenever an operation happens, you may instruct the trigger to do some other related operations. So all those things are not supported in fast load. And duplicate rows are not loaded into a target table. If your source file has duplicates, the row level duplicates, they are automatically eliminated, even though the target table is multi-set. The multi-set, the characteristic of multi-set is to allow row level duplicates. But even your target table is multi-set, the characteristic of fast load is not to load any duplicate records into the target table. They are silently eliminated. It won't show you that this record is being eliminated. At the final statistics, it will give you how many duplicates it get eliminated. Yes, even though your table is multi-set, the fast load cannot load the duplicated data. If AMP goes down, the fast load cannot be restarted until the AMP is back online. So to execute a fast load, you should ensure all AMPs are up and running at that moment. Even one AMP is down, the fast load cannot continue. So this is another limitation of the fast load. So whenever you have these limitations, you may have to work with the workarounds or the different utilities. We have other utilities also as well. So once we learn all those utilities, you can you can be in a position to decide what utility is suitable at the situations. Any questions up here? Any features and the limitations of the fast load utility?
Yeah, Manoj?
Yeah, Manohar, regarding the checkpoints, like how that, like let us say we have 1,000 records. If it is failed at like 200th record, then how it will remember, and it will start from 201, or how it will, the
201.
restartability?
If you have the checkpoint at each 100 records, let's suppose. Okay, so first 100 it will
Yeah.
note down the checkpoint, and the second 100 it note down the checkpoint, and after 20 records it got failed. Let's suppose to 20th record it failed. When you
Yeah.
restart, it will start from 201 record onwards. And
So
anyway,
what about the
it has
duplicates, 20 record?
yeah, that's what I'm going to say. The
Okay,
duplicate
it
rows are
won't.
not loaded as per the characteristics of
Yeah,
the
it
fast
won't.
load itself. Yeah, so it will take care of eliminating of the duplicates. So it starts from 201, and anyway the fast load cannot load the duplicates. So you have the 220 first record onwards to be loaded into the table. Clear?
Yeah.
Manoj? So when we say it inserts a large amount, what's the meaning of large amount? What's a
Large amount
is a
here, there is no
1
fixed threshold. So it is the developer responsibility to come up with, because it contains a lot of factors. The number of columns in the table and the column sizes in the table and the rows. So basically when you say large amount, it is not in terms of the record count, but it is in the terms of the memory, what you are moving from here to there. Okay? You may have 2 columns in the table and some 1 million rows, but here you are moving very less data. Okay? And you may have some 250 columns in the table with all are of varchar 250s or varchar of 64,000, and all the varchars are occupied, and you have only 1000 record, but it is very huge data. Right? So yeah, the huge data means here the memory in terms of the data what you are moving from the systems. So basically, yeah, what you have to do as developer, you try loading the data through BTQ. If it is 100 records, yes, I mean, you know that it is very much small data and you can go for BTEC. But if you are not able to decide if it is a large data and huge data or small data, then what you do, you load the data through BTQ once and note down the timings, and then load it through fast load and note down the timings. If you see significant difference, then you go for fast load, other you go for BTQ. So this is the way how we decide the development phase. Generally we will get the idea, if it is 10 million rows, then no need to test with BTEC, we will go with fast load. If it is 100 rows, no need to test with fast load, you go with BTEC. But if there is any question, is it a huge data or not, then you test it with BTQ and fast load, whichever is taking less time, you go with that. Because see, you compare BTQ and fast load as a car and an aeroplane. Okay, if you want to move within the city, what you prefer? The car, right? You can use flight also, but is it feasible to use a flight to roam around the city? No, right? In the same way, if it is less data, you go for BTEC. You can do with fast load also, no one restrict you, but the resource consumed when you use fast load and the operation what you are doing with the fast load should be matched. So you have to do that feasibility study. So you have to test it. If you have a doubt whether it is a large data or not, then you test with both and you see the resources used, the timings, and then go with the proper utility.
So another question: when we have we sell very huge amount of data, like a billions or trillions of transactions. So can we break this data into pieces and use fast load?
Yep. That's what the multiple separate batches. Yes, you can do that. I will tell you how to do that.
Okay.
Yeah. So there is one more question here. 100 record itself failed, then what happens? 100 record itself failed, that means the checkpoint is not noted down, so it has to start from the first record onwards. Okay? If let's suppose 500 records are loaded and 500th record is getting a failure, means the fifth checkpoint is not yet noted, so it has to start from 401 record. Okay, so during the next checkpoint onwards, everything should be loaded. Okay.
I have one question. This is Radhika. The target table must initially be empty, right?
Yes.
So in case of failure, is there any identifier that can communicate to the load program so that
Yes.
it will start from there?
Yes, there are logs maintained for fast load. Okay, in the DBC tables, there is a specific table which monitors all the fast load utilities currently being running. Okay, so that fast load log which is in the DBC tables will monitor all the utilities, and whenever it is failed, it will see what is the status of it, and it will know it is a restart but not the new run. So it can identify that whether it is a failed node you are restarting or a new load you are initiating. So when we do the practical, you can notice that when you restart, it will say you it is a rerun but not a new run. It will tell us. There is a mechanism.
Manoj, I have one more question, please. Okay. At what stage we use fast load, when we're moving the data from source to staging or staging to the target?
Okay. When you are saying staging to target, what is the input there?
It's data, right? Data from
Data
staging.
from
We have a
table, right? Staging. When you say staging means it is a table,
right?
And target is also a table. So table to table you cannot load fast load, because fast load is basically to load from the data files.
Flat file.
Flat files.
Flat file,
Yeah. Flat files are data sets in case of mainframes, but not from table to table. From table to table it is easy. You write a BTEC.
BTEC, okay. So this is mostly used when the source to the staging.
Yeah. Source files, flat files to the staging area of the warehouse architecture. The Teradata. Basically, the RDBMS should be Teradata. Yeah, go ahead.
Can't we use the source as the RDBMS table and target as RDBMS table in case of fast load?
No, no. You cannot have your input on the table with the fast load. Fast load is intended to load data from the files or data sets to the table, Teradata RDBMS tables.
Okay. But we can do it through Informatica, right? If something in
Yeah,
our
Informatica you can do. That
table
is a specific ETL tool, right? That is a specific ETL tool where you can connect multiple RDBMS with different components.
No, I'm asking about by connecting TPT connection using fast load in Informatica. Can we do like this?
Okay, when you refer TPT, yes, through TPT you can connect multiple data sources.
Okay.
But fast load you cannot do specifically. Okay, so move ahead. Okay, so we saw fast load does the load operation in two different phases. Right, the first phase is called as the acquisition phase. The fast load phase 1 is called as acquisition phase. So what it does in acquisition phase, it uses one SQL session to define AMP steps and another SQL session for log table restart operations. Okay, so fast load uses minimum two sessions. One session is to parse the SQLs what you have written in the fast load scripts, and the other SQL is, another session is to log the information for the restartable capabilities, the checkpoints, okay, the restartability, okay, all these things are maintained by one session. Okay, so when you invoke the fast load, two sessions start working on SQL side and on the restartability side, And then, for example, this is the host file what we want to load. This is the data. And when you invoke the fast load utility to send this data to the Teradata RDBMS table, it will fetch the records into the amps which are available at that moment. Okay, we have 3 amps. AMP2 is busy in some other tasks, and for this moment only AMP0 and AMP1 are available. So these 2 amps start fetching data directly into those amps. So these yellow records. Okay, these 2 amps started fetching the data with no logic. Just whatever is there, just acquire it. Both the amps would work on the data and they will try to fetch all the records within them. No hashing, nothing. Whatever is there and whatever I can pick up and I will load in myself. That's it. Okay, and then within these amps which has acquired the data, they have a process called deblocking. So the deblocking processor of these amps will work on the data and they will do the hashing on the records which are acquired. Okay, when it hashes, what happens? It will find out in which amp this record is suitable or this record to be stored. Right? So the deblocker process of each amp work on the data and it hashes the data and it distributes the data across the amps in which they have to be stored actually. Okay, now here in these records, R1 is distributed to here. Here B1 R1 means this one B1 R1. The record is stored here after the deblocking and rehashing, the hashing. Then R2 is here and R3 went to this amp. Like that, all the records are distributed as per their hash values with the help of the deblocking processor of the amp. Okay, so here they are hashed and
Is there a specific reason?
Pardon?
I have a question. Is there a specific reason why this fast load used only AMP0 and 1, why it did not go to AMP2 also
AMP2 is
for initial
busy.
load?
AMP2 is busy in some other task, some other user is executing some other functionality and AMP2 is serving him. So there is no empty session available in AMP2. We know amps can work 80 tasks at the moment, right? The limitation of AMP, 80 tasks in parallel. So let's suppose AMP2 is already occupied with all 80 tasks. So this AMP2 is not available by that moment and only AMP0 and AMP1 are available. That's where they are fetching it. If AMP2 is also available, then yes, it will also participate in acquiring the data. Okay. So here in this example, we are saying only 2 amps are available at this moment and AMP2 is busy in some other activities. Okay.
And you know, this distribution of data among the amps are not even, right? They can be, I mean, the large amount of data can go to one amp and the smaller chunk of data goes to the other.
The acquiring was saying, yeah, the acquiring can be anyway. Okay, the yellow records are raw records, which are fetched from the file. So it is the acquisition, what happened. So it can be happen based on the workload of those amps. If AMP0 is more concentrating on fetching the data, it can get more data, and AMP1 is busy in some other task and is having some less resources to load, it will have the less data. So acquisition, yes, it could happen based on their capability at that moment. But after acquiring, the deblocker system of each amp would start hashing the records and they distribute the rows across the amps as per their hash values. Here these white records are hashed records, which this amp should supposed to store within it. But still these records are not sorted based on the hash values. They are distributed based on the hash values but not sorted. If you see the hash values 42Z, it should be 24Z if they are sorted based on the hash value, for example. Okay, so here what happened is the data from the host file are acquired into the amps and redistributed based on the hash values but not sorted based on the hash values within the amps. Okay, so whatever records we got without sorting order of the hash values, they are inserted in the virtual disks in the amps. Okay, so it just acquired the data and each amp got the records what it's supposed to store in it, and without sorting the rows based on their hash values, they were just simply set in here in their corresponding virtual disks. So this is the completion of the first phase, the acquisition phase. So by the end of the acquisition phase, what you have, the records are acquired into the Teradata tables and they are distributed but not sorted based on their hash values. So that is the status of the table by the end of the first phase. And when it starts the second phase, in the script, in the fast load script, whenever it encounters a statement called end loading, then it starts the second phase called end loading phase. What happens in end loading phase? It is very simple. Whatever data is stored in the virtual disks for that load, it will just rearrange or reorder them as per their hash values and store them. Okay. So R4, R2, RZ are sorted R2, R4, RZ as per their hash values. So whenever you have an end loading, it just sorts the data based on their hash values and store into the virtual disks. So after this operation, the data is available to the users because after sorting it will release all the locks on the table, the fast load utility, and the table is available to the users. After the end of phase 1, you cannot access the table. Yet during these two phases, you cannot access the table. After completion of end loading phase, the locks are released and then only the users can access this table. Okay. Whenever the fallback option is there, the fallback rows are also maintained in this phase. Okay. So this is the way how the fast load works with two phases. Phase 1, where it acquires the data, hashes the data, distribute the data, and without sorting the data as per the hash values, it stores the data. And in the end loading phase, it will sort the data within each amp based on the row hash values and release the logs and maintains the fallback information if required. And so the users can start accessing the tables. Okay. So this is the script, sample scripts. The first statement what we use in fast load is the begin loading, the database name and table name.
Manohar,
Yeah.
Manohar, I have a question.
Mm-hmm.
By end of the phase 1, do we have duplicate records eliminated or it's done in second phase?
Yeah. In the phase 1 itself, it will eliminate the duplicates.
Because here it's not sorted, right? It just dumped the data from file to the MP.
Yeah, it is dumping, but while loading itself, okay, it will verify some way, some mechanism is there, and it won't allow duplicate records to be loaded. Okay, so your question is whether it is done in phase 2 or phase 1. Is it?
Yeah, correct.
Okay, not very much sure. Yeah, as it is sorting here, it could eliminate in the second phase. So here, when it loads in the target table itself because it won't use the work table as a multi-load. Okay, so it loads everything here, but while sorting the data, it can identify if there are two rows which are with the same data, but it could be in different amps also, because it is a row level duplicate it eliminates, not the key level, index level duplicates, right? So yes, there are chances at the sorting phase or the end loading phase it would eliminate the duplicates. But finally, before releasing the log, you won't have the duplicates in the first one. Okay, you can say the second phase, okay, which enables the duplicate record elimination because it is the sorting, so there is a chance of comparing the records here. Okay.
Manor, in this phase 2, you are showing two tables, right? One is the red one, is the one is the green one. So our assumption is that in the first phase it has been loaded into the red one, and
No,
the
no.
green one is also the same table, right, with the sorted data.
Yeah, yeah. So it is to represent same table. Okay, the red table means the raw data. It is pulling the data, and after sorting, it is pushing the data into the same table in same virtual disk. So this is same virtual disk. The red is raw, the green is after sorting. It is not two different tables, it is same table, but after sorting it is loading. The arrow you consider
So
it
these
as
are
upper arrow.
virtual disk. Okay. So these
Up
are
arrow.
V disk or this is a table?
V disk, V disk. The V disk
Or these are
tables.
V disk.
Yeah. So it is same virtual disk. What it is reading and it is writing. The arrow should be read as read here. Reading and sorting and writing. Okay.
Manoj?
Mhm.
So data is transferred in the form of like in the rows or in form of a 60 core kilo, what do you call 60 core data block?
64 kilobytes of memory is used to transmit the data. So it is only rows. The
So
memory is used to spool the data into that memory. It accommodates in the memory of that size 64 kilobytes, and it will keep the data into the amps. In the acquisition phase, if you observe, each amp would use 64 kilobytes of memory to spool the data and then insert into the amps. Again 64 kilobytes, again load, again
So
64 kilobytes.
when we say insert into amp, so it's inserting into spool space, whatever in the available in the amp, right?
Insert into amps.
So
Or the statement?
the statement is that the amp has my memory, or they have a spool space, or they have permanent space.
Spool space. Permanent space is once it is inserted into the actual final tables, but before that it uses all spools. Okay.
So if the fast load fails at the first phase,
Mhm.
like during the acquisition phase, right?
Mhm.
And the data, what you call the data transfer is not completed yet. So how do we go for it? Like
Yeah, we'll come to that. Once we see the script and execute it, okay, we have the scenarios where what actions we have to do at each level. If it is failed in before acquisition, after acquisition, we have the scenarios. We'll come to that.
okay.
Are you going to tell us on this space estimation before starting these huge fast load jobs, or how do we determine whether the spool space we have available is sufficient to complete this fast load?
We have that query, right? I mean, how to see the spool space available for this user at that moment. You can see that spool space available for the user, and if you feel that the space is enough, you can start invoking the fast load.
No, my question is, we do know how much is available, but fast load, do we have to do the calculation before the start, like one record occupies this much kilobytes of space and these many millions of rows times, and then see whether it is sufficient or not, and then proceed, or in the real world, how do we do this load jobs?
See, here it won't occupy the space which is required to load all those million records at once. What it does, per amp, it uses 64 kilobytes at a single time. So it is not that it will occupy the whole spool to load all the 10 million records and then it start loading it. Got it? So 64 kilobytes of memory it uses, and it fetches the records and store into the pump space. And then again 64 kilobytes. The 64 kilobytes is the spool you use, and once it loaded to the target table, it is the pump space. Okay, so how much spool space you are going to use?
Okay, so it is loading chunks of data.
Yeah, chunks of data with the 64 kilobytes of spools. But once it is placing it, it is placing the data in the pump space. So it is not the spool space you calculate. You have to calculate the pump space, whether your database has the space available to accommodate the 100 millions of data or not. But spool, yes, it is always has 64 kilobytes.
Okay, got it. Thanks.
And then let's see the syntax of the fast load script. Begin loading, the database name, table name. So we are declaring the table what we are trying to load with this fast load script. Okay. So the name of the empty table, and it is not a view. We are not loading the view here. Okay. So table name we had to mention, and it should be empty. That table we declare here with the begin loading statement. And then error tables. Okay, we'll mention it as error files because internally they are stored in files, but we can access them as if they are tables. Select star from error table, but internally they are files. So the keyword here it says error files, but they are basically files, but we can access them as a table. So you can mention the database name dot the table name. You just declare it. You no need to create it. You just declare it where you have the create access, so that the fast load with your user ID, it will try create these tables. Okay, so database name error table 1 and error table 2. So there are two error tables. The first error table captures the constraint based errors. That means if you have a constraint not null on the table, but you are trying to load some null values, or you have a range constraint, it has to load only 1 to 100, but you are loading 101. So all those constraint based errors are captured in error table 1 in the first phase. Okay, in the second phase, it captures the unique violation errors. Okay, the primary index based errors, the primary index based duplicates. If it is a unique primary index and you are trying to load the duplicate primary index record again, then those unique violation errors are captured in error table 2. Okay, that's where we have two error files. The first one is to capture the constraint based errors in the first phase, and the second one is to capture unique violation. They are not row level duplicates. Please ensure they are the primary index level duplicates. In case your table is of unique primary index and you are trying to load multiple rows with the same primary index, those records are captured in the error table 2, not the row level duplicates. Row level duplicates are not captured anywhere. They are silently eliminated. Okay. And then checkpoints. The checkpoint takes an integer, and if this integer is within a number 60, it takes that number as the number of minutes it has to consider as a checkpoint. So you can give checkpoint in terms of minutes. If the number is within 60, it will consider that as number of minutes you want to maintain your checkpoints. Okay, if I say checkpoint 15, then 15 minutes is considered as a checkpoint. If I say 60, it will consider 1 minute for each checkpoint. So whatever data loaded within this 1 minute, after the minute it will maintain the logging of the checkpoint status. So these many number of records loaded, these many number of records loaded, like that. If you specify a number more than 60, it considered as the number of records. If you specify 100, then it means after each 100 records we have to log the checkpoint status. Like that, you can either manage the checkpoint in terms of time or in terms of the number of records. If the number is less than 60, it considered as the minutes or the number of records. And then if you want to load the data which is exported as a indic data, the indicators, then fast export, which is the other utility which exports the data, there you can load the data at the indicator mode where it will preserve the null values. If you want to load such data, you have to provide the indicators variable here so that it will allow the null value preservation. Yes, this is the begin loading statement typically, where we will declare the target table, the error tables, what is the checkpoint and indicators, error limits also if required, everything will declare here. Yeah. And then see the sample script, the total script here. The logon statement, so which is very first statement for the utility to establish a session with the Teradata. And then the begin loading, the target table name. If your default database is there, then no need to mention the database. Otherwise, we have to mention the database name also along with the table name. And the error files, 2 error files. First one is 2 constraint based errors and second one is unique violation errors. No need to create them. They should not exist before execution first time. Okay, and fast load will create them for you, and if there are no errors, they will be dropped at the end of the execution. If there are errors, then it will have the records populated and you have to go through these error tables, see the error records, fix it, and then rerun it. But if there are no errors during the load, these tables are dropped automatically. So checkpoint mentioned, and then as it is loading data from the flat file, we have to declare how the data file looks like, how many columns are there, what is the data type, what is the formats, everything we have to define, because it is load utility. So it is loading, the input is from the file. From file we are not sure what should be the data types, what will be the data types, so we have to manually declare the column names, number of columns, data types, everything. From which file? The data input file. We have declared with the statement define. In BTech, what is statement we used? Using. Right? We used using and declared it. Here the syntax is define. Then the actual load statement insert. Okay? It loads all the data.
We mentioned how about the definition of error 1 and error 2 tables? Like we did not define the structure, right?
Yeah, we'll come to that.
How do?
Okay. Okay. So it start insert the data with this statement. This is the actual import statement. Yeah, whatever data in this file, the fast load will read in this format and start loading into the table. And finally, the end loading statement, which tells that the load the equation completed and start do the second phase. In the second phase, it will sort the data in the amps as per their hash values, and then logging out of the session. Okay. And there
One
are
of the file input file is
yeah.
the input file is file equal to data in file. That is the file name.
Yes, this is the file name. Here we are in the same path. That's why we are not giving the full path, the absolute path, but it is a relative path. If you want to give the full path, C:/ something from Windows, you can do, or the root directory and the path you can do in the Unix environment. This is the data file. Okay. And there are some features while defining. If you want to do any transformation, a little transformation, you can do that. Okay. If you see, the data types are enclosed within parentheses. The character of 25, again this 25 is enclosed with parentheses. Why it is? Because we have another option of doing transformations here. See, trans date, if it has the value 0000-00-00 in the data file, when you are reading this data, you convert it as null and load into the table. Okay, the transformation you can do within declaration of the variable. What does it mean here? Whenever in data file this particular column has a data value like this, convert it to null, because date having this format doesn't mean anything in the tables, so we just wanted to make it as null. Like that, some simple transformations you can do here. Yeah? Otherwise, zero if. So if it is null, then you want to make it as 0, you can do that. Yeah. And while loading, if you want to restrict the number of records to be loaded, you can use the statement record 1 through 1000. That means first record onwards to 1000 records. If you specify 100 through 1000, then it will skip the first 100 records and then starts from 100 and it loads up to 1000 only, not till end of the file. If you eliminate this through, then it will start from this particular number and it will go till end of the file. So you can restrict from where you have to start and how many you have to load by using this record and through. If you don't use through, then it means till end of the record. In record, you can mention the number of records from which it has to start the loading. For example, I have 1 million records, and if I say record 1000 through 500, then what happens? It skips the first 100 records, it starts from the 100 and then loads till 500 only. Like that, you can control the number of records which has to be loaded in fastly. And then if something happened and error table is populated with the data, then how do you see the data? So this is the structure of the error table 1. Error code, error field name will be there from the error table 1. So this table is created by whom? The fast load. We don't create it. We just declare the name. But once the fast load creates it, the structure would be like this: error code and error field name. So which would give you the information what is the error and in which field it has happened. And there is third column which captures the entire record. You can see that. And then duplicate index violation happens. Then we can query the second table. So let's start from error table 2. You will see the structures. So which would give you all the duplicate errors, unique violation errors. And here error codes, if it is a normal constraint or if it is a range constraint, the corresponding error codes and through which field the error occurred and the entire record can be seen. So here it is about the checkpointing, which we already discussed. Okay? This is to verify that rows have been transmitted and processed. When you specify checkpoint, after each number of each chunk of those many number of records or those many number of minutes of records loaded, it will load the checkpoint. Specifies the number of rows transmitted before pausing to take a checkpoint and verify receipt by AMPs. If the checkpoint parameter is not specified, fast load takes a default checkpoint. Because beginning of the phase 1 and every 0.1 million input records and end of the phase 1. Fast load can be restarted from previous checkpoints. Performance note. Okay, we have to identify what is the good number to put as a checkpoint. So suppose if I have 100 millions of rows and if I say my checkpoint is 100 records, so how many checkpoints I have to maintain? Almost 1 million checkpoints I have to maintain, right? So maintaining checkpoint is also a resource consuming operation. Observe, after loading those many number of records, it has to make a note in the log table that these many number of records are loaded. So if you ask this operation many times, again it will slow down the load operation. Okay, so we have to give a reasonable number of records as the checkpoint. If it is 10 million, then you give at least a 0.1 million as a checkpoint. Okay, so that you can end up with 100 checkpoints. Like that, you have to do a feasibility study and identify how many number of records we have to use as a checkpoint. Yeah. Basically, it is 10 to 15 minutes. Yeah. So default, it will take 10 to 15 minutes checkpoints. The in-mode routine, just for notes I have given here, data is considered and the in-mode routines where it will do the pre-processing of the data before loading through fast load. It will do the in-mode, the internal transformation, then it will generate an output file, and that output file is considered as input for the fast load and loads the data into Teradata. Okay, so whenever you use in-mode, this is the operation performed. First in-mode will be invoked and the output of in-mode is used for fast load to load the data into Teradata. Okay, so we'll continue tomorrow, on Monday. So tomorrow is a holiday. We'll meet on Monday and we'll continue the fast load and we'll see the practical scenarios of fast load. Any questions, anyone up here?
Yeah, I have one question. If the checkpoint, it's mentioned beginning of phase 1, every 100,000 records, end of phase 1. Those are the defaults, right?
Yeah.
So if the assumption is the table is going to have more than 100K, then only this assumption is going to work.
Yes, yes. And even
normally
you don't
fast load.
Yeah, even you don't have these many number of records, without a checkpoint everything will be completed if you don't mention.
Yeah, we don't get the first checkpoint itself.
Yeah.
Okay. I was under the impression this fast load is going to work for more than 100,000 because default is this. So okay.
Yeah. So even 100 records without checkpoint it will complete it. Yeah, go ahead please.
Yeah. So you said that fast load is only for loading. So only insert operation is useful in. I mean, we'll use only insert operation in fast load or update.
Yes, only inserts.
So in real time, in what case you will decide fast load? Only for initial load or?
For staging loads,
Like,
yes. Basically, if you are doing a staging load from source data file to the Teradata table, the first place you may use this fast load if the data is very huge.
Okay. So, for example, in real time, we have a situation like we need to create a table and load it, and the second run onwards, it has to create a delta file and load it. So in this case, you are going to use only fast load for the first run only, right? After that, MI load any other iteration, right?
Yeah. So if it is a change capture process, you have to do what you do at the staging. Okay, before loading through fast load, you take the backup of the yesterday's data into some other table and make this table empty and load today's data, and then you compare the old table data and the new table data and do the full outer join to do the change capture. Got it?
Manohar, Sandeep, this fast load we can run through our VMware, right? Wherever we have installed our SQL assistance.
Yes, yes. We'll see tomorrow. Yeah, the practical session of fast load.
Oh.
Once I log in, I will show you how to write the script and how to load the data. So we can do through our VMware machines. Yes.
Manoj,
Mm-hmm.
the fast load supports the typecasting. They will change the data types.
Yeah, only once it supports. When it enters loading, it supports the format changing only once.
So
See
only,
here,
only for one
format.
data type, or we can change multiple fields. We
No,
can change.
for a column, once. You see format. If it is in different format, translate. It will try to convert into this format and load.
So we can change for all ones.
Yeah, for all the rows, the format will be changed. But per a column, once.
Thank you.
Okay. Okay. Fine then. We'll meet on Monday. Tomorrow is a holiday, and I will send you the feedback details as an attachment. Please go through that and please provide your feedback in Teradata forums. Yeah, I prepared the document. I will send it to you. Thank you very much. And you work on your case study
Is it
also.
possible for you to send these? Is it possible for you to send these slides?
Yes, I already sent.